Hi guys, our learning intention for today is to be able to solve problems involving F, G and C. So this is part 2. We're going to look at more examples of these questions. In this video, we're going to look at questions from exercise 9.6. Okay, exercise 9.6, question 5. Show that if the circle x squared plus y squared plus 2gx plus 2fy plus c equals 0, touches the y-axis, then f squared is equal to c. Okay, so let's look at the diagram. When your circle touches the y-axis, we can see that the radius of your circle is equal to the x-coordinate of the center of your circle. So when the y-axis is a tangent, i.e. when your circle touches the y-axis, the radius is equal to the absolute value of g. So we say the absolute value because we are only taking the positive of your x-coordinate. You ignore the sign. So we're only looking at that distance. Okay, let's see how we can use this information to show that f squared is equal to c. From page 19 in our log tables, we know that r, the radius, is equal to square root of g squared plus f squared minus c. That means that the absolute value of minus g is equal to the square root of g squared plus f squared minus c. Okay, let's try and simplify this equation. We're going to square both sides of our equation to get rid of our absolute value. This gives us the absolute value. This gives us g squared is equal to g squared plus f squared minus c. Our g's cancel out and we're left with 0 is equal to f squared minus c. And then rearranging our equation gives us f squared is equal to c. Let's look at question 5, part 2. Using the result from part 1, find the equation of the circle that contains the points A, 2, 3, and B, and touches the y-axis. Okay, so again, in any type of question where we want to solve for g, f, and c, or find the equation of the circle, we let our equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c equals 0. From here, we want to solve for g, f, and c. To do this, we need to use the information that we're given to set up 3 simultaneous equations and solve for them. We know from part 1 that f squared is equal to c. So the first thing I'm going to do here is eliminate the c from my equation of the circle and substitute it in with f squared. So this gives us x squared plus y squared plus 2gx plus 2fy plus f squared is equal to 0. Okay, so now I just have 2 unknowns in my equation of the circle. Let's try and solve for those. We know that the point 2, 3 lies on our circle, so substituting this into our equation of the circle gives us 2 squared plus 3 squared plus 2g times 2 plus 2f times 3 plus f squared equals 0. Simplifying this gives us 4 plus 9 plus 4g plus 6f plus f squared equals 0. This leaves us with 4g plus 6f plus f squared equals minus 13. All right, we have one equation with f and g. Let's make another equation that has f and g. We know that the point 2 minus 5 is also on the circle, so substituting this into our equation of the circle gives us 2 squared plus minus 5 squared plus 2g times 2 plus 2f times minus 5 plus f squared is equal to 0. This leaves us with 4 plus 25 plus 4g minus 10f plus f squared equals 0. And simplifying this and moving our constant to one side of the equation gives us 4g minus 10f plus f squared equals minus 29. We can now use equation 1 and 2 to solve for g and f simultaneously. Let's write both equations underneath each other. Okay, so we're going to try and cancel out our g and our f in this case. To do this, we're going to multiply our second equation by minus 1, which gives us minus 4g plus 10f minus f squared equals plus 29. Solving for our remainder, and we're left with 16f equals 16. And dividing both sides by 16 gives us f is equal to 1. We've now found that f is equal to 1, so we will substitute this back into our first equation. So we're going to substitute it into our equation here to solve for g. So 4g plus 6f plus f squared equals minus 13. This gives us 4g plus 6 times 1, so substituting f for 1, plus 1 squared equals minus 13. This leaves me with 4g. 6 plus 1 gives me 7 equals minus 13. Bringing our 7 to the other side gives us 4g equals minus 13 minus 7. 4g is equal to minus 20, and therefore g is equal to minus 5. Okay, we've now found the values of f and of g, so we're going to find our value of c next. Well, don't forget that at the very start we stated that f squared is equal to c, so substituting in our value for f gives us 1 squared equals c, and therefore c is equal to 1. Now that I found f, g and c, I will substitute them into my equation of the circle, and I get x squared plus y squared minus 10x plus 2y plus 1 equals 0. Okay guys, that's question 5 on exercise 9.6. Similarly, if we were told that our equation lies on the x-axis, then our radius in this case is equal to the absolute value of f. And substituting this into our radius equation would give us g squared is equal to c. So if your circle lies on the x-axis, you know that r will equal f, and you can use this to solve for and substitute in g squared equals c. Okay, let's try another question. This is exercise 9.6, question 11. Find the equation of the circle that passes through the points minus 2, 2, 5 minus 5, and has the line 3x minus 4y equals 35 as a tangent to the point 5 minus 5. Again, we want to find our equation of the circle, so let your equation of the circle be x squared plus y squared plus 2gx plus 2fy plus c equals 0. And from here, we want to solve for g, f, and y. Sorry, we want to solve for g, f, and c. So to solve for g, f, and c, we need to set and make 3 equations with g, f, and c in them, which we can then solve simultaneously. Let's make our first two equations with the points we're given. We're told that a minus 2, 2 is on our circle, which means that minus 2 squared plus 2 squared plus 2g times minus 2 plus 2f times 2 plus c equals 0. This gives us 4 plus 4 minus 4g plus 4f plus c equals 0. And then adding together our like terms and bringing our constant to the other side gives us minus 4g plus 4f plus c equals minus 8. Let's call that equation 1. Alright, now we need to make a second equation that has f, g and c in it. We know that 5 minus 5 lies on your circle, so substituting this into our equation of the circle gives us 5 squared plus minus 5 squared plus 2g times 5 plus 2f times minus 5 plus c equals 0. This gives us 25 plus 25 plus 10g minus 10f plus c equals 0. And adding together our like terms and bringing our constant to the other side gives us 10g minus 10f plus c equals minus 50. So we have our second equation. Now we need to use the information given to us to make a third equation that has g, f and c in it, or at least two of those variables. So what do we know? Well, we know that the center of our circle will be minus g minus f. We know that a point on the circle and the tangent is 5 minus 5. Okay, so this is what I know so far. I also know that my tangent is 3x minus 4y equals 35. So how can I use this information to make a second equation? Well, I know that my tangent is perpendicular to the radius of your circle. So the slope of the tangent is equal to minus a over b, which is equal to minus 3 over minus 4, which gives us 3 over 4. If the slope of our tangent is 3 over 4, then the slope of our radius is perpendicular to this, which means that the slope of our radius is minus 4 over 3. I now know what the slope of my radius is, so let's fill that into my equation for the slope. My slope is equal to y2 minus y1 over x2 minus x1. And 2 points that are on my radius line are my center and 5 minus 5. So let's call my center x1, y1, and let's call my point x2, y2. Substituting this information into my equation for the slope gives me minus 4 over 3 is equal to minus 5 minus f over 5 minus g. We're going to now manipulate our equation so that we can have a third equation that has our two unknowns f and g in it. Let's simplify this. Minus 4 over 3 equals minus 5. Minus times minus gives me plus f over 5. Minus times minus gives me plus g. Let's cross multiply to get rid of our fraction. And we're left with minus 4 times 5 plus g equals 3 times minus 5 plus f. Expanding our brackets, we're left with minus 20 minus 4g equals minus 15 plus 3f. And bringing our f and g to one side of the equation and our numbers to the other leaves us with minus 4g minus 3f equals plus 20 minus 15, which is 5. And then multiplying everything by minus 1, so flipping our signs, gives us 4g plus 3f equals minus 5. So this is our equation 3. So to find our equation 3, we find what the slope of our radius is, substitute in our 2 points that are on the radius line to our slope equation, manipulate and solve. Okay, I now have 3 equations which have g, f, and c in them, and so I can solve these simultaneously. Alright, here's my 3 equations. I'm going to take equation 1 and equation 2, and I'm going to eliminate the c from them. Okay, so writing down equation 1 and equation 2, I want to eliminate my c, so I am going to multiply my second equation by minus 1. This would give me minus 10g plus 10f minus c equals plus 50. Okay, and then solving for our remainder gives us minus 14g plus 14f is equal to 42. Let's divide by our common factor in this case. So 14 isn't common, so I can divide by 14 and I'm left with minus g plus f equals 3. Okay, so I now have 2 equations with g and f in them. Let's write them underneath each other and solve them simultaneously. I've got equation 3, 4g plus 3f equals minus 5, and equation 4, minus g plus f equals 3. I'm going to multiply my second equation here by 4 to cancel out my g's. This leaves me with 4g plus 3f equals minus 5, and my second equation now of minus 4g, 4 times f gives me plus 4f, and 3 times 4 gives me 12. Solving for my remainder, I cancel out my g's, and I'm left with 7f is equal to 7, and dividing both sides by 7 gives me my value of f equals 1. I've now found my value of f, so I need to find my corresponding value of g. To do this, we substitute our value for f into our equation. 3g plus 3f equals minus 5. This gives us 4g plus 3f equals minus 5, which gives us 4g plus 3 times 1 equals minus 5. 4g plus 3 equals minus 5. 4g is equal to minus 5 minus 3. 4g is equal to minus 8, and g is equal to minus 2. I've now found my values for f and g, so I need to find my value for c by substituting my values for f and g into any of my original equations 1 or 2. Okay, so taking equation 1, minus 4g plus 4f plus c equals minus 8, and substituting in f and g gives us minus 4 times minus 2 plus 1 plus 4 times 1 plus c equals minus 8. This leaves me with 8 plus 4 plus c equals minus 8. 12 plus c equals minus 8. C is equal to minus 8 minus 12. That's bringing your 12 to your other side. And c is equal to minus 20. I now know that f is equal to 1, g is equal to minus 2, and c is equal to minus 20. So we're going to substitute those into our equation of the circle. X squared plus y squared plus 2gx plus 2fy plus c equals 0, and we're left with x squared plus y squared plus minus 4x plus 2y minus 20 equals 0. Okay guys, so you can see the pattern in these types of questions. You're trying to make three equations with the information you have and then solve them simultaneously.